So, batteries, so exciting.
It is in this world.
It is. So, most people are familiar with what they have been using for decades. And so now with lithium, there's a lot of questions with it. What's involved? Do we need to add anything more to our system? How long do they last? Is it worth the price tag? There's a lot of questions, so we can get to those question and answers, but let's you know a little bit about the company. The presentation really just going to be talking points, and then I want to make sure that we have Q&A at the end, and then if the conversation needs to go further, I'll be here all day. So down at the vendor booth, and then I can come to your trailer, and whatever you'll need if you have any questions or concerns of what the batteries you have. Definitely Steve, who is the owner of Lithionics, he wanted to express his gratitude to you all. Lithionics has a lot of things in common with all of the travel trailer. They're family owned. Steve is the owner. His wife is the office manager. Her name is Melissa. His son is Alec. He is a black belt for Kaizen. If you're familiar with Kaizen and ISO and how to make standard operating procedures, make the company flow better. So he's there as well. One of the manufacturing managers, his son is Matt. He's also there, just had a kid. Just had a child a couple of days ago, the name of Theo. The marketing manager, his name is Phil Silverhorn. He had two sons working for Lithionics. And one right now is the manufacturing manager. He's over all the manufacturing. He's a code writer. He does a lot of our programs for the company. So Lithionics is not a humongous corporation. You walk in there and you tour it, you're going to see about 8 people in the front office. 80% of us know each other from church. That's how I found out about the job. Before I was working for Lithionics, I was a banker, and I had an uh-oh baby, and Steve, the owner, had an uh-oh baby. My uh-oh baby came when I was 40, his uh-oh baby came when he was 60. So I pinned him in the back of church, and I said, how did you do it? And he was the first person to know. And then when I was looking for a different opportunity so that my wife didn't have to work, I wanted to work from home, I asked him if there's a place for me in the company, and he generously opened a way up. So I am a product manager. I handle a lot of the big companies. We all separate, there's 4 of us. So one gentleman by the name of Dan Musto handles all of OEM. And you all are considered OEM, right? Big companies. And so he does a lot of the OEM, and he manages outside sales teams. And those outside sales teams are usually in Elkhart, Indiana, the home of the RVs and trailers. And so we wanted a staff and engineers in Elkhart, and he manages them. So that's one. Phil Silverhorn, who I mentioned, the market manager, has been over there for 10 years. He manages a lot of the yacht industry. Nordhaven Yacht is a humongous company for us. So we do a lot of yachts, just catamarans in Miami, Ocean Planet Energy. So some of our big customers he handles. Jackson Dettori is another product manager. If you ever call in, you might get him. He handles government contracts. Raytheon is a big company for us. He handles Disney. So if you ever see the Disney parade, that's off of lithium batteries. Same thing with Universal. And some of their rides are using lithium. It's kind of a ride in the middle, and they need to have certain energy in different parts of their ride, so that's also us. So that's Jackson, and then myself, who manages all the travel trailer. And I don't know if you're familiar with all these van builders that are coming up and making Sprinter vans and transit vans, and they're, house vans and Mercedes and Transits and all that. So I handle a lot of that market, including the trailer market. So that's a little about us. We have, let me see if there's anything else. So yeah, people don't really realize what's lithium being used for right now. The government contracts, it could be as simple as something that's floating in the middle of the ocean, being powered by one solar panel, and it's detecting missiles going across. So lithium needs to be used. It's a different idea, but at the same time, it's coming along. We've been in business for over 12 years. We've been a leader in it. Some companies have been in business for 5 years. So we have learned a lot along the way. And so let's start off just by these talking points, I'm sorry. So, I should have told him that in the first part where it says the engineering behind the world's best designed by RV owners, for RV owners, trailers too. He just had this for an RV company. So what's the difference? When it comes to batteries, for us, it's all about number one is safety. So when Lithionics started, we had a choice. We could get ISO certified and really put our focus in ISO, which is, again, the way a company runs and standard operating procedures, or invest in UL listing. So it costs tens of thousands of dollars if you get a single battery and we want to test that battery and give it to UL. And UL wants to blow this battery up. That's their intent. Where can I find a flaw in this battery? We have to do that with every single battery that we're going to produce in a wide production. Someone's buying 100 of them. So sometimes we'll get a contract and it's 10 or 12, whatever the case, but then we get bigger OEM contracts and they say, I want UL certification. So we now have to spend the money, get it to the point that's ready to be tested and send it to UL. So Lithionics went the UL route. Now we're ISO and UL, but the key thing for us is safety. And there's a reason why we have the Bluetooth app. If you have lithium batteries, you'll see the lithium now. That Bluetooth app can be overwhelming, but just know it's designed for safety. If you take, and we can even touch on this since I'm here, if you take an off if you take a competitor's battery, and if you have, let's say, 6 of them, and they're all in parallel, which means the positive and negatives are connected and it's adding energy. And if one is going awry, one needs to come offline, one is in default, how would you know? If it doesn't have Bluetooth and there's no fault indication, you would have absolutely no clue that this battery is in a possible thermal runaway state. You just don't. You don't know. So that's why the Lithionics Bluetooth app was designed for safety. It gives you a fault code. If that fault code appears and it's red, that means call me, or more people call Jason, but they'll call Lithionics, they go right to me, you have my cell phone number, and that's when you troubleshoot it. And it doesn't mean there's something wrong with the battery. It could be there's something wrong with the install even. I'm not saying something wrong with the install. It could mean that even your parameters, your charging parameters in your inverter may have just erased somehow, and the app will tell you. The app will tell you if there's something going on in the system that needs to be addressed. So that's the first point, is Bluetooth app. With that Bluetooth app, we have firmware updates. So we're always constantly trying to get better and better and better, especially with the state of charge percentage. People go, well, my state of charge percentage is 90. Okay, that's understandable. But I just charged it 100%. I just did it. And it gets fully charged overnight, connected to shore power, and it should be fully charged. Sometimes what people do is they will discharge at a small percentage, and then charge at a small percentage, and discharge and charge, discharge and charge. Here's a beautiful thing about lithium, but this is a challenge when it comes to percentages, state of charge percentage. When you charge your battery 100%, it's hooked up to the charging source, it's fully charged, your battery should show 14.4 volts. 14.4 volts. Now, when you disconnect the batteries from the charging sources, it actually settles down to 13.6. Doesn't mean that you're going, wow, it was a 14.4 and now it's 13.6, there's something wrong. No, it's settling down at 13.6. As you use your battery, it's going to, the voltage will stay high almost the whole time. It's literally at 50% when it reaches 13.2. So at 13.2 volts, you're still got 50%, and it's still giving high voltage. So everything's running really smooth, it's getting clean energy, it's lasting really long. But then, there's such a difference between 13.6 and 13.2, that state of charge percentage is really hard. Because it's a difference of 0.4 volts. So the only way that you really have a clean state of charge and know that percentage is accurate is that state of charge resets at 14.4 volts. So we always tell people, charge them all the way up at least every 2 weeks to to 14.4. That state of charge will reset. And they'll be accurate. They're going forward. So the nice thing about lithium, it holds really high voltage for a really long time. But the only way to know true state of charge is amps in, amps out. If you have a 640 amp hour system, it knows you're at 640 amp hours, you're at 100%, boom, and then you use 100% of it, or 100 amps of that. Now the state of charge is understanding, right? Amps in, amps out. That's the only way it really knows. Because voltage stays high the whole time. Does that make sense? Did I muddy up the waters? Good? Okay. You might have another question about that later, but I wanted to get that. Now, that's the reason I bring it up, because notice this point says, in the field firmware upgrades, we're always trying to get better at the state of charge. We're always trying to get better on our app, and you have a lifetime Bluetooth app. The next point, RVC CAN bus. People are like, what's that? Simply put, it's all about integration right now. Well, you want, in cars now, I tested this with my Jeep. I bought a Jeep and I wanted to put a remote start in it. And it had 2 wires coming out of the remote start. And you can connect these 2 wires to a strip of plugs. And with these 2 wires, it can do almost everything with 2 wires. Unlock, lock, start the car. What it's doing, those 2 wires, is just giving different voltages and commands to the system. And that's, with the RV world, it's called RVC, that's the protocol, and the cable is called CAN bus. So now, when you're looking at inverters, when you're looking at solar charge controllers, if it says CAN bus, RVC, that means you can connect your batteries to that system and integrate the batteries into it just by 2 wires. It's a plug and play. But we have the technology for that on our systems for RVC CAN bus. It's just all about integration. People want integration. I'll skip over a little bit. What's really important about the Never Die Power Reserve, a competitor's brand, if their battery reaches a very low voltage, they tell them to jumpstart it. Get the cables out and jumpstart it and wake the battery up. So how many of us, you don't have to raise your hand, many of us have had a mower, and I had this with my in-laws mower. He had a push mower, and he would charge the battery and leave it on the charger. And he would take the battery off next week and plug it in, and then use it, and then keep it on the charger, and as soon as he just forgot about it. Right? He'd lawn the mower, put it on, so I'm gonna charge it later, it's just sat there. Well, lithium, like any battery, is gonna die if it just sits. But it only goes a little bit. Like our lithium is about 2% every month. It's gonna lose about 2% every month if it's just sitting there. But when a battery gets so low, you have the battery, which in lithium is the cells, we'll get to that. Then you have the brain, which is called a battery management system. That brain protects everything. If the BMS looks to the cells and say, hey, am I on? Do I have enough power to turn on? And if it drains so low that the BMS cannot turn on, then you just have a dead battery. You try to use it, you try to power it, you try to charge it, and it's not charging. It's because the battery, the lithium battery, is so low that the BMS won't wake up. It won't turn on. So what we've done is we want to protect everybody against that. So we have what they call, well, what's called here is power reserve. So remember I told you that 13.2 is 50%. If you use your battery so much that it goes down to 12%, that's still very high voltage, 12 volts. But in the lithium world, that's somewhat low. So at 12 volts, the battery says, I'm done, I'm gonna turn off, and I'm gonna make you turn me on. And now I'm telling you, now it's time to charge. Now the reason why we did that is because you have 10% total energy still left there. You still have a lot of energy that you could use. In the middle of the night, maybe you want to turn on the light or whatever the case is. You don't want to hook up the generator, plug in the shore power, whatever the case is. You can turn your batteries on and they'll turn on. 10% reserve still left. But we did that for a lot of the RV industry because you can engine crank on our lithium batteries. That's mind-blowing. So you're able to, if your starter battery's dead, your house battery's at 12%, they turn off, you can turn them back on and start your engine off the lithium battery pack. So that's the benefit of that power reserve. One, it's a protector for you all, that it turns off and lets you know. And then also you still have that 10% reserve. Now before the battery pack should die, and it shouldn't say that, it should turn off, the inverter should turn off first. So the battery usually turns off at 12 volts. Your inverter, low voltage, would be like at 12.1, 12.2. You can ask Jason. I think he has like 12.2. So that's going to turn off first at 12.2. Then your batteries will stay on because it didn't reach its reserve voltage yet. So that's the benefit there. So don't worry. You should not have your batteries turn off. Your inverter will usually turn off first. We'll touch on that. Internal heater kits. So if you have the two GTX 12V320s, that's the Elite 2 package. The Elite 2 package, those have an internal heater kit. I'll show you the data sheet on that, but the internal heater kit is big. If people want to know about the temperature cutoffs, charging is way more particular. Charging a battery in lithium, it's more particular. It doesn't want to be charged if the battery pack, an internal cell temperature, I'm talking about inside the battery, reaches 32 degrees. If you're trying to charge at 32, the BMS will turn off. Discharge, they'll let you. It'll go all the way down to 0. So discharge is less particular, but charge is a little more specific. So the heater kit on the 320s is interesting. It actually will turn on at 35 and off at 40. On at 35, off at 40, and again, I'll show you a little bit later the data sheet of how efficient that is. The GTX 12V320 is also aluminum alloy encoded. It uses like the whole compartment as a heat sink. Not saying most of it's copper, so the only heat you're going to get in your battery compartment may be from your inverter, but the battery itself, you're not going to feel. You're not going to feel any heat coming from the sides or the top of the battery. It's very low resistance. You don't have to worry about that. Let's move on. So why people are going to lithium? Interesting. So our business has quadrupled, literally quadrupled in the past 3 years. And it's because of things that just the movement. If you look here, state parks, they're banning generators. In California, they're making a move. Tallow generators 2024. You look at the limited sites, RV sites. It's stating, I'm not sure where they got these numbers, 500, 600,000 RVs, only 10,000 RV sites. So more people want to be off-grid and choose where they want to park, in between trees or wherever they want to go, don't have to worry about service. That's a major point. So then, of course, integration that's mentioned here. But the trend is there, showing that people are going to call for lithium because lithium is fulfilling a role that you cannot do with AGM or lead acid, period. You just can't. It's still an option for those that are going from site to site, plugging into service. That will always be there. You always have those customers that have the place that they go to, the lots that they own. But for many that are looking for different options, it's kind of a must now with lithium. If you're planning on running air conditioning or using your coffee pot or reduction stove top, lithium is kind of the only option of going off grid. I'm going to take a lot of your time. We did talk about entry level. So this is your GTX 12V320. That again is an Elite 2. You can see the space. Usually each of those 12V100 amp hours is about 12 inches. This one is in 20 inches. So it's super petite, only 6.5 inches wide. When you're looking at amp hours, you have to consider AGM amp hours. So remember, AGM, lead acid, you can only use 50% of the rating. 50%. So if you're saying like 320 amp hours, that's 600 amp hours of AGM. Now on top of that, you have to parallel and series connect those AGMs. So now you have all that resistance and impedance that's happening when you do those connections. So you're doing this with one battery, 320 amp hours. So it's only 70 pounds. So when you're looking at this one battery, they're listing 12 100 amp hour lithium batteries. But if you compare this with AGM, you actually need to double that, 6. of AGM batteries. Just one battery can do it. So that's the benefit of our batteries. And this was the heater kit that I told you about. If you look at some of the results, we tested it, and 20 degrees Fahrenheit. I had a gentleman yesterday said that using 20 degrees Fahrenheit is his battery department reached. It's 4 amps per hour. 4 amps, per hour. It ran 25% of the time. So it was 1 amp per hour there. If it's in a negative degree freezer, 1.75 amps per hour. So that's just showing how efficient that battery's heater kit is. For those that have the 12V130s, that right there is an impressive battery. We did a side-by-side comparison with a competitor commonly known as the Say Battleborn. And then you can see some of the efficiency on the right side. What doesn't those have compared to ours? We talked about the reserve power, turning off at 12 volts. It doesn't have that. We'll touch a little bit on resistance. Resistance is big, impedance. So I'll give you, try to make one up, like a hose. So if you want to run water from this corner, and you want to run it off of the patio there, but you have short hoses. And you have to connect each one of those hoses. Or you have a really long hose that's thick. What's going to run better? What is the motor going to run better? It's going to run better when you have a thick hose, one of them going from that corner to the edge of the patio. But when you connect little hoses along the way, all of that is resistance. It's harder to push the water out. Now, when you're dealing with competitors' brands, it's really important to look at their cell technology. What type of cells are they using? So for the most part, you're going to have batteries that use little cylindrical cells. It's like oversized double A's. And for this company, they have 140 cylindrical cells. So 140 little cells, and then they tack weld on a nickel plate those cells. And that collectively makes 12 volts, 100 amp hours collectively, but they're doing it with 140 cells. So what you're seeing in this battery in the 12V130 is 4 cells, not 140, 4 cells. If you look at the GTX 12V320 in the Elite 2 package, that's 12 cells. And those are laser welded, not tack welded. So laser welded cells. The benefit is that each of those cells is very dense, very light, and allows less impedance, which again, allows it to start a car engine, a V engine, because there's no resistance, there's nothing holding back that voltage. So that's the benefit of, again, Lithionics, but also our cell technology. Testing is huge, so I like to call it the birth certificate, where batteries get their birth certificate. And there's a later picture on this. So every battery that we have goes through a quality control. Part of the quality control is we completely charge it to 100%. We completely discharge it all the way down to reserve, and well, actually past reserve to low voltage, and we make sure that the amp hours is there. And then we certify it. Where we make really specialized batteries, and let's just say we test it and it came back at less amp hours, let's say 5 less, 6 less, then we just offer a discount because we tested it, we fully charged it, fully discharged it, and this is what it came back. And so we test every battery and fully charge and discharge. Going back to resistance, when there is resistance in the line, especially with electrical, it heats up. I'm sure everybody knows it gets warm. So we do thermal testing on our batteries as well. We look at the thermal, make sure there's no loose connections. We had an issue where the BMS in the battery was saying 280 degrees. So let me go back. So the Bluetooth app tells you the internal cell temperature and tells you the temperature of the battery management system. Usually the temperature of the battery management system is the ambient temperature. What's the temperature in the battery compartment? But in this situation, he had a loose connection on top of the battery, and it wasn't tight. Because of the impedance, because of the resistance, it's trying to make that connection, it got hot. And the BMS were at 280 degrees Fahrenheit. And of course they call, there's something wrong with your BMS, what's going on? Why is it showing 280? And we're trying to figure out what's going on. And it's, what is it called? Arkham's razor, always start at the simplest. Test your terminal connections. And sure enough, the battery, it wasn't tight. That's all it was. So I know you hate us, we always start at the smallest. Check your terminals. Torque them down the spec. And, yeah, we tried that. We'll try it again. Oh, yeah, they call back. Yeah, it wasn't tight. So those are certain things you just want to look at. With the BMS, again, the BMS will tell us he had a loose wire in the battery management system, the Bluetooth app told on it. Because we were able to narrow it down. And this is part of the battery of the Bluetooth app. So you can kind of see, so I guess it'd be on your left. There's your state of charge percentage, then there's your voltage. So your state of charge percentage, again, is irrelevant if you don't fully charge your batteries to 14.4 volts. Someone says, I charge it, it's 100%. Well, what's the voltage? It's at 13.5. Check your system, check the parameters on your inverter. It should bulk charge, which means it's going to take it from 12 volts and it's going to charge it really fast to like 14.4. If that setting is at 13.5, that's why. We're narrowing down in the system what's wrong. So my battery's fully charged, I plugged it in, but it only reached 13.5. Check your settings. Oh, it shows 13.5. Change it to 14.4. So it's telling on the system, is really what it's doing. The current it's going to light up in red. If you're discharging, it's going to light up in green if you're charging. That's in amps, and the power is your watts. Your battery, again, is the BMS temperature, 60 degrees Fahrenheit. Oh, I'm sorry, that's the internal cell temperature. The BMS is 71. The state is showing on, and battery time remaining. That changes if you're charging or discharging. It's going to tell you how much to full, how much to empty. The color just changes depending on what you're doing, charging or discharging. So you kind of view it as time left to full, that's charging, time left to empty, that's discharging. So that's your time remaining. And then your status codes. Anytime that you see a status code in green, there's nothing wrong. It's just telling you that something's balancing. It's letting you know some things are happening in the battery. There's nothing wrong with that. Interesting on the battery life tracking. You can do like remaining amp hours. That's like your gas gauge. Again, remaining time. Now, what's interesting, if you look at total consumed amp hours, that's phenomenal. Because that helps us to hold us to our warranty. Total amp hours consumed. So we can see how long this person has it. Let's say he had it for 1 year, 2 years, 3 years, supposed to have a 4-year warranty. I think it's 2,000 life cycles. But if he blows through the amp hours, and he's just full-time remaining, we can see the total consumed amp hours. Doesn't mean that we're not going to honor warranty manufacturer defects, but we're able to see that this person just used tons of amp hours. Or you get someone just a weekender, and they didn't use barely any amp hours. We can see the total consumed. We call it throughput. How much did this amp hours, how much amp hours did this person use? Let's see, firmware updates. Cell voltage, that's again making sure that all the cells are charging and discharging evenly. And if someone ever has an issue with their battery, we can have them do a data logging, and they send us a screenshot, we send that to the engineers, and every second it's giving us data. If someone has an issue overnight, we'll have them record a data entry, they send it to us, and we can problem solve it.